Hi everyone. The purpose of this video is to give you a walkthrough to what I'm expecting for you to do in the first phase of the project. So let me get this started over here. Do the screen sharing, make sure we're on the right board here. Okay. All right. So the first thing that the project asks is in the phase one, it says you need to create a set of functional and non-functional requirements based on the project description given above. You're welcome to increase the set of requirements beyond what is described. However, it cannot be contradicting it. Okay. So normally in a regular project, we begin with a whole bunch of use cases, which could be broken down into smaller functions, function requirements. Okay. But because this is not a requirements engineering course, it's a design course, so we're going to skim a little bit the requirements phase and just basically head immediately to writing down the functional requirements of the system, okay, and the non-functional requirements of the system as well. Okay. The one in the functional, okay, so I'm going to list them down 1, 2, 3, 4, 5, 6. In reality, a number of these requirements would have actually related to a particular use case or use cases happening. And sometimes what we want to do is we want to be able to group together those use cases, sorry, those function requirements into families of related functions. So if we're looking at a university system, we'll see something like drop a course, add a course, audit a course. All of this are related to, we'll say something like registration. Okay, make payment, check with outstanding payments, and so on. This is related to payments and so on. And so this is what you're going to be doing after you create the set of function, non-function requirements. What you want to do is in number 3, you're going to be creating an architecture of the system. But before we get to that, we're going to create a system context model. So this is my system, just like we did in 225. And we got to realize who are our actors. Obviously, we got to do this like a skim mode because it's not really a requirements course. So we got to realize who are our actors. And then we obviously realize what are the things that they want. And from what they want, we got to realize then what are the function requirements, as I said before. Okay. And afterwards, after we realize the function requirements that we have, it's a case of, in number 3, this is where everybody's getting confused. It says create an architectural design of the system. Okay, a little later part in that sentence, it says you will need to create an initial design of the main subsystem of your system where the classes will be placed in. So what happens is that we start off with a big system like this. Okay, everything inside is empty. Okay, all we know is that we have our function requirements here, and then we said that maybe the first 3 relate to, we realize relates to registration. The other 3 relates to payments. Okay, the next 3 relates to, for example, faculty affairs. Okay, so maybe I'll decide I'm going to have one subsystem called registration. Okay, one for payment. Okay, and then one for faculty. All right. Later on, what's going to happen? This is a zoomed out view. Once I zoom in, okay, inside this subsystem called payment, there's going to be a whole bunch of classes inside. Inside this subsystem called registration, it's going to be a whole bunch of classes inside. Similarly, over here, it's going to be some classes inside. And to know that we're on the right track, we look for 2 things. Okay, we look for a high level of cohesion. Okay, what is cohesion? Means the classes between inside one package, they should have a high relationship level. Okay, and a low level of coupling, and the coupling are the ones that are inter package relationships. Okay, we don't want to have too many of the blue lines, we want to have a lot of the black lines. Okay, and obviously there's got to be some coupling, otherwise there's just three independent systems. So there's got to be some coupling, but we want the coupling to be as minimum as possible. Okay, and we want the cohesion to be as high as possible. All right. Um, the premise behind this is, had I had two subsystems over here, okay, this is the way it was supposed to be. You got a black one, you got a blue one. The blue one's got those classes. The black one's got those classes inside. There's supposed to be a high level of cohesion over here and a high level of coupling over there. Now let's just say I have taken a couple of those classes from here and a couple of those classes from here, and I, by mistake, and I would say that that would be a mistake, taking those ones, put them over here, taking the green ones from here, put them over here. What I'm going to end up with is the situation as such. Okay, I got my classes. Okay, here's the blue. Okay, got my classes as well. All right, a couple of the blue we put over there, a couple of the other blacks we put over there. What's going to end up happening is that the number of interrelationships would increase, okay, because I've just moved it from one place to the next. So the lines, they still stay there, and then the lines get dragged between the different packages. So that increases the number of coupling. The other thing we also notice is that the relationships between the different classes inside a package would decrease, and that's because they shouldn't belong to each other. Okay, so that's not really a good design. Okay, I mean, we begin with a white page. We haven't even decided what are the subsystems. At a later point, you're going to be creating those classes, but your guide at this point is to realize, based on the requirements that I've come up with and I have over here, all right, you'll see that logically some of these requirements tend to relate to each other. And believe me, if they tend to relate to each other logically, chances are this would be a candidate for a subsystem, this would be a candidate for another subsystem, this would be a candidate for another subsystem, right? And your design will be good. You know, you might want to try one or two designs. Chances are your first design is not the best. So it's good to come up with multiple designs. All right. Now, there's one part in step number 3 that says you got to create the architectural design should incorporate multiple architecture patterns. Okay, this is exact like the layered and the client server and the repository. Okay, those specifically, those three tend to be a standard in all what you would hear in the industry called enterprise computing. Okay, so what I want you to say is, I want to say something like, you know, we're going to be using the client server architecture. We're going to use a 3-tier, and this is why. Here we're going to put the presentation at the client. We're going to put the application logic at a server and the data at another server. And this is the reason why we're using, right? Okay, maybe a couple of lines saying why you're using the client server architecture. You will be using it. Believe me, you will be using it. Okay, I just need you to deploy those architectural patterns that we've already described before. Okay, I want you to say, you know, we're going to be using, for example, the layered. Okay, and here are the layers. This is where we're going to put this in here. We're going to put this in here. This is exactly the same thing like you had in that question that you had in the midterm. Okay, maybe a little later on, we're going to be using the repository. Okay, so everything that we have, all our classes, we're going to be dealing with a repository. And the reason we're using a repository is because we want to have, you know, you'll say something like we're going to have one version of that data. We might have a backup for it, but only one active at a time. Okay, so that's basically it for the first phase. I mean, if you follow what I just said, it shouldn't really take more than 30 minutes to actually complete that first phase. Okay, The bigger work comes in the second phase. And that's it. Best of luck.